Okay, we're back with example 2 in our notes for graphing logarithmic functions. And in example 2, we have an a of positive 1, that's the coefficient in front of the log function. Then our b is the base, and the base of this log is positive 3. Then the c is the coefficient on x, so our c is 2. And then we need to be careful here about the h, because in order to find the h, we have to first get this in transformation form. And when you look at the notes we did for transformation form, notice the c, the coefficient on the x, has been factored out of this quantity x minus h to the front. So before I can identify that h, I have to divide out the c. So I'm going to factor this 2 to the front, and that'll leave me with an x minus 1 on the inside. So now I can see that my h is not a 2, my h is actually a 1, right? I have to take that that c value and factor it to the front to find the h. Then the k is the constant at the end, which is a positive 3. So remember that our vertical asymptote is controlled by that h value. So my asymptote is at the line x equals h, which is x equals positive 1. So I can go ahead and dash that asymptote onto my graph. Then I'm going to identify my anchor points, and I use the base of the logarithm to do that. So all parent graphs of log functions have an x-intercept of 1, and then we go through the point b comma 1, which our b is 3, and then we pass through the point reciprocal of b comma negative 1, and the reciprocal of 3 is 1/3. Okay, then to take care of the vertical dilation or reflection, we multiply the y-coordinate of each of those points by the a, and our a is 1. When we multiply a number by 1, we get that same number back. So I'm going to go ahead and skip that transformation since it doesn't accomplish anything for this function, because the a was 1, there's no dilation or reflection with respect to the x. So then we're going to divide the x by c, and our c is a positive 2. Okay, c controls horizontal dilations and reflections in the y-axis. So this c equals 2 is going to produce a, if we look back here to our transformations, right, when c is an absolute value greater than 1, it's a horizontal shrink. So when we multiply divide each of these x's by c, that's going to give us a horizontal shrink as our dilation. So 1 divided by 2 is a 1/2. 3 divided by 2 is 3/2. And then 1/3 divided by 2 is 1/6. Then each of these y values is going to stay the same. And now we can do a horizontal translation by adding h equals 1 to the x coordinate. That's going to shift our graph to the right 1 unit. So we take 1/2 plus 1, which is 3/2, and the y stays the same. Then 3/2 plus 1 is 5/2, and our y stays the same. And then 1/6 plus 1, which would be 6/6, is 7/6, and the y stays the same. Okay, then our vertical translation, we're going up 3 units, so we add k equals 3 to each of the y values. So all of these x coordinates are going to stay the same, and we're going to take 0 plus 3, which is 3, 1 plus 3, which is 4, and then -1 plus 3, which is 2. And then we can plot these transformed points on our graph. So 3 over 2 is 1.5. So we'll go over to 1.5 and then up 3 units and plot that point. And then we go to 5 over 2, which is 2.5, and then up 4, and we plot that point. And then 7/6 is about 1.2, and then up 2, so we're pretty close to the vertical asymptote there. And then you've been given this extra guide point here at 5.5, 5. So we're coming along the vertical asymptote through these guide points, and that would be our transformed logarithm. Okay, the domain is based on that vertical asymptote. So our domain starts at 1 and heads to positive infinity. And then the range is all real numbers, negative infinity to positive infinity for all logarithmic functions. Okay, that brings us to the secret question for this lesson. And on a piece of scratch paper, I'd like you to go ahead and complete all of the information for log base 2 of the quantity negative x plus 4 and then minus 3. So you're going to find the equation of the vertical asymptote, identify your a, b, c, h, and k values, find your anchor points using the base, and then take those anchor points through the transformation process and plot them on the graph. The extra guide point at -4, 0 has already been given to you, so your function is going to pass through that point. And then once you've got your graph, you can identify the domain and range.